All right, so today we're starting 9-6, and we're going to be solving rational equations and their inequalities. Okay, so when you have rational equations for all fractions, okay, the fractions have to have a variable in the denominator. And you can eliminate the fraction by multiplying each side by the LCD. So that's what we're going to be doing today. We're going to be multiplying each side by the least common denominator. When we do that, we can get extraneous solutions. So we're going to check our solutions, and I'm going to show you a way to do that today using the domain of each function. Okay, so we are going to start with part A. Okay, so for A we have 9 over x minus 7, okay, minus 7 over x minus 6 equals 13 over x squared minus 13x plus 42. Okay, so your first step is going to be to factor if you need to. And then after you factor, you're going to multiply by the LCD. So the reason why we multiply by the LCD is to undo the fractions. So when you're factoring, we're going to start with x and x to get x squared, multiplies to positive 42, but adds to a negative, so they both have to be negative. So you're going to have negative 6 and negative 7. And then whatever your LCD is, that's what you're going to multiply by. Okay, so the LCD here has to contain x minus 7 and x minus 6. This has both of them, so we're good with the LCD. When you multiply something by the LCD, you're multiplying each side. Okay, so when you're doing that, if you were to multiply this side by the LCD, you'd have to distribute, okay, to both of those. And so I'm going to show you a few different ways that you can write this. So I want you to write this out just like me in the notes. So we just factored that, so we're going to leave that as our factored form. All right, so when you're multiplying each side, you're going to multiply by x minus 7 times x minus 6, and you're going to multiply this side by x minus 7 times x minus 6. Okay, on this side you can see the x minus 6 and x minus 6 is going to cancel, the x minus 7 and the x minus 7 is going to cancel. On this side though, you have to distribute to both of them. So when we write this out, how we're going to write it out is we're going to multiply by each term. So instead of writing it out like this, when we go to different steps, I'm going to have you write this so you can do the cross out. What you don't want to do is you don't want to cross out the x minus 7 with the x minus 7 and the x minus 6 and the x minus 6 and then just write 9 minus 7. That's not correct. Okay, so we're going to write it like this so we can cancel them out. If they do cancel, then you would just be left with 13 here. Okay, and now you can cancel out the x minus 7 with the x minus 7. When you do that, you're left with 9 times x minus 6. For this, you have the x minus 6 that cancels out here. And so you're left with negative 7 times x minus 7 is equal to 13. Okay, and then from there, you can just distribute and solve. Okay, and then we'll get 9x minus 54 minus 7x plus 49 equals 13. So 9 times x, 9 times negative 6. Negative 7 times x, negative 7 times negative 7. And then we'll just combine our like terms. So 9 minus 7 is 2x. Negative 54 plus 49 is negative 5. Okay, and then if we add 5 over, we get 2x equals 18. Divide by 2 to get x is 9. Right, so when we are multiplying these out, I'm going to write it like this so you can cancel them out, and same thing on that side. Here, I wanted to write this out so you guys can see the distribution, but you can do the distribution without writing out this step, that's fine. And then you're going to do your check. So for the check, what we're going to do is we're going to find the domain. So in the domain, you can't have the denominator equal to 0. Okay? In this case, your denominator is your LCD. So you're going to set your LCD equal to 0 and you're going to solve. So set the LCD equal to 0 and solve. Okay, so our LCD is x minus 7 times x minus 6. We're going to set that equal to 0. So we know that x minus 7 equals 0 or x minus 6 equals 0. And then we're just going to solve for x. So if I add over the 7, I have x equals 7, x equals 6. So these are the two restrictions. Okay, x can't be 7 or x can't be 6. So all you have to do is look at your solution. Okay, so if the solution is not 7 or 6, then there is no extraneous solution. Okay, so since x does not equal 7 or x does not equal 6, there are no extraneous solutions. Okay, so your check is just going to be you telling me what x cannot equal, and this is going to be your final solution. X is equal to 9. Alright, the next one we're going to do, there are actually two different ways to start it. You can either factor first, which is what we did in the last one. Or those you might recognize something else you can do for B. Okay, but we are always going to be multiplying both sides by the LCD. And that is because we want to undo the fractions. So we want to get rid of those fractions. Okay, so if we start by factoring, how can you factor 2x plus 2? Yeah, you just take out the GCF, which is the 2. Okay, so some of you may have noticed the denominator for the first two fractions is the same, and if your denominator is the same, what could you do? Yeah, you can just combine them. You can add them, right? You can add fractions if you have the same denominator. Okay, so we're going to go ahead and do that. So you can only do that if you have the same denominator. Okay, if you don't, then you'll just be multiplying each side by the LCD. So if I add x plus x, I'm going to get 2x minus 8, and that's over 2 times x plus 1, and that equals 2x minus 3 over x plus 1. Okay, so your first step is to factor, your second step is to multiply by the LCD. So the LCD in this case, you just start here. So this is the 2 times x plus 1. This already has the x plus 1 in it, so you're good. Okay, and we are going to multiply both sides by the LCD. So when you're showing that, you can just show that you're multiplying this side by 2 times x plus 1. You're multiplying this side by 2 times x plus 1. And then go ahead and cancel out what you can. Okay, so on this side, you can cross off the 2 and the x plus 1. That just leaves you with 2x minus 8. Okay, on this side, the x plus 1 is going to cancel out with the x plus 1. So you're going to have to multiply 2 times 2x minus 3. Again, this is something where you could distribute here and write the distributed version there. That's fine. So you have 4x minus 6 equals 2x minus 8. We're going to move all the x's to one side, all the numbers to the other to solve for x. So I'm going to divide. I get x is equal to negative 1, and then I'm going to do my check. So again, your check is just finding out what your domain is. Okay, so we know that the denominator cannot be equal to 0, which is your LCD. Every single time you do this, you're going to be using that LCD. So we have factored the LCD into 2 times x plus 1. When you are solving this for 0, if you set each factor equal to 0, when you get something like this that doesn't have an x in it, that just means this is not going to give you a solution. So you can't solve that for x. There's no x to solve for. So that's not a problem. We can just solve this one. So we know x cannot be negative 1. So if x is equal to negative 1, this means there is a no solution. Okay, that would be your answer, no solution. So now we know this is extraneous because that's a restricted value. Okay, we can't have x equal to negative 1 because then the denominator would be 0 and we can't divide by 0. Another way you may see the no solution written is like this. It means the null set. So if you see that symbol, know that that's what it means, but you're welcome to just write no solution. Okay, so if x is equal to negative 1 and that's your restriction, it is an extraneous solution. All right, and then I'm going to have you start the last divided by t squared minus 9 plus 4 over t plus 3 is equal to 1. Again, remember, these are two steps. Factor and then multiply by the LCD. So if you're not sure where to start, you always want to start with the factoring. Alright, so the t squared minus 9 is going to be that difference of two squares. Okay, and so this is t plus 3 times t minus 3. So once you have that, you're going to multiply both sides by the LCD. So your LCD is just going to be t plus 3 times t minus 3. Okay, so hopefully we at least got that step where you factored. And if you have 1, right, the denominator is just 1. So that is your LCD. When we write this out, I'm going to do the distribution so I don't have to write it in 2 steps. So I'm going to multiply everything by the t plus 3 times the t minus 3. So I'm multiplying 8 over t plus 3 times t minus 3 by that. I usually will write this first and then do the times on the side. Okay, so every term gets multiplied by that t plus 3, t minus 3. One reason why I like you to write it out is so you can cancel out and multiply correctly, because sometimes students just multiply the wrong things together. But when you have it written out like this gives you a chance to see, okay, t plus 3 divided by itself is 1. This divided by itself, that cancels. So you're left with 1 times 8, which is just going to be 8. When you move on here, remember, this is a quantity. It's in the bottom of a fraction. So the t plus 3 and the t plus 3 cancels out. So now you're left with 4 times t minus 3. And then 1 multiplied by this means I'm just going to multiply those together. We've already multiplied them. It's t squared minus 9. When you multiply two binomials, you FOIL. So t times t is t squared. 3t minus 3t is going to cancel. 3 times negative 3 is negative 9. And then we are going to distribute the 4. We're going to combine our like terms. So I have 8 minus 12, which is negative 4. And when you find yourself in a situation where you have t squared and t, what process should we do? What do we have to do with everything? Yeah, we got to get it all on one side so that we can factor. Okay? Or you can use the quadratic formula if you prefer. So, yeah, we're going to move the 4t over and that negative 4 over. And then I'm going to factor. I'm going to put the 0 on this side. So this is a pretty simple trinomial to factor because this is a prime number, right? Multiplies to negative 5, adds to negative 4. So we have negative 5, positive 1. So because they multiply to 0, we know either t minus 5 has to be 0 or t plus 1 has to be 0. So t is 5 or t is equal to negative 1. Okay, and then we're going to do our check. So with the check, you might have both of these be a solution. One of them might be a solution. Okay, so we know the denominator can't be 0. So we'll set that LCD equal to 0 and solve. So if we have t plus 3 times t minus 3 is equal to 0, what are the two values t can't be? Yeah. Okay, so this isn't 3 or negative 3, same thing here, so this is going to be your solution. Okay, so both of those are viable solutions for this. Okay, and those are all of your equations. Now we are going to talk about how to solve an inequality. We are going to be using some intervals, which is a skill we learned earlier this year, so some of that might feel familiar to you. And when you have a rational inequality, that just means there's at least one rational expression. A rational expression is just a fraction with a variable in the denominator. So we're going to use these steps. These were taken right from your book. I think they're helpful. So the first thing we're going to do is state the excluded values. That's the same thing that we were doing with the domain. Okay, so the values for which the denominator is going to be 0. Then you're going to solve the related equation. Okay, the related equation is what you get when you multiply both sides by the LCD. So after we multiply by the LCD, we will be writing out an equation to solve. And then we are going to use the values from steps 1 and 2 to divide a number line into intervals. Okay, to divide a number line into intervals. So the previous steps, you have to take step 1 and 2, the excluded values and the solutions to the related equation. You have to use both of those for the intervals. And then we're going to pick some test values. We called them test points before. And we use those to figure out which values are going to satisfy the inequality, which means which ones make the inequality true. So we're looking for true inequalities. Okay, or true statements. And then the true statements are going to be your solutions. All right, so we're going to solve the inequality algebraically. So our first step is 3 plus 2 divided by t is greater than 8 over t. 3 plus 2 over t is greater than, actually, let's make this greater than equal to 8 over t. Okay, so your first step is to find the excluded values. So you're going to find your LCD. Okay, so the LCD for this is t. T is the denominator. Okay, so then all we have to do is find where the denominator is 0, and in this case it would be 0, right? You can think of it like this. We know t couldn't be 0 there. This is going to be one of your values. And then for step 2, we're going to solve the related equation. So to get the related equation, we said we have to multiply both sides by the LCD. Okay, so we're going to multiply 3 times t plus 2 over t times t, and then 8 over t times t. So when you multiply by the LCD, you are multiplying all of those by the LCD. So when you do that, you have 3 times t, which is 3t. The t's will cancel out here, and you'll be left with 2. And then the related equation, we are going to change that into an equal sign for the related equation. And then we're just going to solve this for t. So we have 3t equals 6. Note for this, it's going to be equals. This is going to be the related equation, but your answer will be an inequality. Okay, so the related equation is always formed by multiplying by the LCD. When you're solving an inequality, it is the same steps as solving an equation. Okay, so if you left it as the inequality there, that wouldn't be a big change. But for steps 3 and 4, you have to use those values to divide a number line into intervals. Okay, so we're going to do steps 3 and 4 here. And we're going to make a number line. And we have 2 values, the 0 and the 2. So what we're going to do on the number line is just write the 0 and the 2 in numerical order. So you have 0 and 2. This is going to split the number line into 3 parts. So you have to write an inequality for this part that I've just highlighted. Do you guys remember what that inequality would be? T is what compared to 0? Less than 0. Okay, so t is less than 0. This would be t is between, equal to. And then this is between 0 and 2. And then your last interval is t is greater than 2. So you have to find which one of these is true and which one is false. Okay, if it's equal to here, then you're going to have equal to in these intervals. And to figure out which one is true, all we have to do is pick test points. So your test point can be anything in the interval. You're going to be plugging them in, so the lower the numbers are, generally the easier that will be. So you can pick any value that's less than 0. You don't want to do the equal to because that happens in 2 intervals. So that's an indeterminate value. So it just has to be less than 0. So a good test point would be -1. Between 0 and 2, a good test point would be 1. And a value greater than 2, 3. Again, it can be any number that's greater than 2. So to figure out if they're true and false, we just plug it into your original equation. So if you plug in -1, this is 3 plus 2 divided by -1 is greater than or equal to 8 over -1. Well, what's 2 divided by -1? Just -2. So this is 3 plus -2, which is going to be what? Yep. And then 8 divided by -1 is -8. Okay, so that's going to be true, a true statement. Okay, and then what I have to see for these are your, I need to see the inequalities. Okay, so how you're getting whether they're true or false. And then if you plug in 1, you have 3 plus 2 over 1 is greater than or equal to 8 over 1. So again, here, this is just going to be 2, so 3 plus 2 is 5. It says 5 is greater than or equal to 8. That is false. So again, we just want to see what that inequality is. And then the last one is 3. So we have 3 plus 2/3 is greater than or equal to 8/3. And when you have the fractions, you can either write them both as mixed numbers or both as improper fractions. So 3 plus 2/3 is just 3 2/3. I would change it into an improper fraction. 3 times 3 plus 2 is 11. And once you have the same denominator, you just compare the top. So is 11 greater than or equal to 8? Yes. So that's going to be true. So then your solution is going to consist of the true intervals. So this is going to be part of your solution, and this is going to be part of your solution. If you have more than one interval, you connect them with an OR because they can't be true at the same time. So t is less than or equal to 0, or t is greater than or equal to 2. And that's how you're going to write your solution. T is less than or equal to 0, or t is greater than or equal to 2. All right, and then for part B, I want you guys to do the first 2 steps. So find your LCD and then multiply by your LCD. Okay, so what do we find for the LCE? 2m is right. Okay, so once you know it's 2m and you set that equal to 0, you know that m can't be 0, and that's one of your key values. Okay, and then I asked you to do the second step, which is just multiplying everything by 2m. So when you're doing that, it's 2m times 1 over 2m minus, and then I always put this one first. It doesn't matter if you do the times first or not. And you can make this into your related equation. That is fine. If you do it in this step or the next step, doesn't matter. Okay, I just want you to have everything multiplied by 2m so that you can do your cancellation. So the 2m cancels out with this 2m, so you're left with the 1. Here, m cancels out with m, so you're going to take a negative 3 and multiply it by 2, so this is negative 6 equals, the 2's are going to cancel, so you just have negative 5 times m. Okay, so then you're just going to solve for m here. 1 minus 6 is negative 5, so when you divide by negative 5, you will get positive 1. And now you have those two key values, so you can make your number line. Okay, I'm going to do my number line here just because I feel like I have more room. And then you just have to make sure you put these in order. So the 0 has to go first, the 1 is going to go second. If you remember the order of the number lines, it's going to be the same pattern every time. M is less than this first value, M is in between these two values, and M is greater than this last value. And you get to pick whatever test point you want. So you can pick any value that is a less than 0. I'm going to choose negative 1. Okay, again, you can't pick this value because it's in two of them. Between 0 and 1, I'm going to go with a half. And greater than 1, I'm going to go with 2. Okay, and then the main thing I'm looking for here is just that you have plugged in your values into that expression. Okay, so the negative 1, I'm just going to plug in here. So this is 1 over 2 times negative 1, so it's 1 over negative 2, minus 3 over negative 1 is less than negative 5 over 2. When you have minus a negative, remember that turns into plus. So this is negative 1/2 plus 3. Do you guys know what negative 5 over 2 is as a decimal? Yeah, negative 2.5. And then negative 1/2 plus 3 is 2.5. So this is 2.5 is less than negative 2.5. Is that true or false? False. 2.5 will be greater than the negative. We're going to talk about that in the next one. Yeah, your pattern. Yep, there is a pattern. Okay, so then for your 1/2, when you plug in a half, if you do 2 times 1/2, do you guys know what that is? It's just 1. And then 1 divided by 1 is going to be 1. And if you want to write this as negative 2.5, because that's easier to compare, that's fine. Okay, so 1 divided by 1 is 1. When you're dividing by a half, it's the same thing as multiplying by what? 2. So 2 times negative 3 is negative 6. And we have negative 5 is less than negative 2.5. Okay, and then this is going to be true. Negative 5 is a lower number than negative 2.5. Okay, and then some of you might remember that when we did this earlier, you should have an alternating pattern. If this is false, this should be true, and this one should be false. When you're doing these tables, if there's 3 of them, I do want to see what your inequality is. And this one is 2, so this will be 1/4 minus 3 over 2 is less than -5 over 2. Okay, this one I think it's a little easier to think of it in terms of decimals, because 1/4 you know is 0.25 minus 1.5. So if you have -1.5 and you add a quarter to it, you have -1.25. Okay, is that less than -2.5? No. This is going to be false. All right, so your solution is whatever interval or intervals are true. So your solution is 0 is less than m, which is less than 1. All right, and then there's one more type that you could see. And that is going to be similar to x over x plus 2 plus 1 over x minus 1 is less than 3 over 2. Alright, so I want you to start by identifying what the LCD is, so that you can find out what your restrictions are. And then once you find your LCD, set it equal to 0 so you can find the restrictions. So when you're doing your LCD, let's start with the first one. So what, according to the first fraction, what do you have to have in your least common denominator? Okay, so I should see that you have x plus 2. That's part of it. Right? This one tells you that what else has to be part of it? X minus 1. Now this is the tricky part, because some of us are going to think, oh, I have 2 here. But remember, this is x plus 2, so that's different. So the 2 also has to be a part of the LCD. That's going to go in front. Okay? That's not going to make a difference for whether or not you get your values in step 1, but it is going to make a difference if you don't multiply by that in step 2. Because if you try to set this equal to 0, okay, that's not going to give you a value, but here we have x can't be -2, and here we have x can't be 1, and so those are going to have to be 2 values on our number line. And then we're going to solve the related equation, which the related equation comes from multiplying every term by the LCD. So we're going to multiply 2 times x plus 2 times x minus 1 by, I'm going to do some color coding for this one. So by x plus 2. We have to multiply the second one by the LCD. Okay, and we can change that to the related equation. Okay, and now we can cancel and solve. So I want you to give that a try. So make sure you're taking the time to write out what you're multiplying by and then canceling them out so you can see what's left. So this one does have 3 things left. You have 2 times x minus 1 times x. We are going to be multiplying those all together. You can distribute the 2 first to get 2x minus 2 and then multiply that by x. That's fine. So that will give you 2x squared minus 2x. Okay, so you have to multiply the 2 times the x minus 1 times the x. Some of you might even just write the 2x minus 2 times x out here. You might do this part in your head, the distribution, that's fine. And then with this one, the x minus 1 and the x minus 1 cancel out. So look and see what's left over. See how you have plus 1 times 2 times x plus 2? Well, 1 times 2 is just going to be what? 2. So you just have 2 times x plus 2 left. So to simplify, you distribute. So that's going to give you plus 2x plus 4. Again, you're doing the distributive property. And we'll combine it with its friends down here. Okay, then you have the equal sign. So the 2's are going to cancel out here. What you're going to be left with on this side is 3 times x plus 2 times x minus 1. Okay, to simplify, you can FOIL first and then distribute by 3, or you can distribute the 3 to the x plus 1 and then FOIL. I like to do the distribution at the end, but it really is not going to matter. Just don't distribute to this as well. When you're multiplying, you just multiply one by the other by the other. So x plus 2 times x minus 1 is x times x squared. 2x minus 1 is going to be 1x. 2 times negative 1 is negative 2. So I have 3x squared plus 3x minus 6. And we're going to clean up this side. So the negative 2x and the 2x make 0, so you just have 2x squared plus 4. And this is what we had on the bottom of the last page. If you have an x squared and an x, we're going to move everything over to one side. Okay, so then we'll have 0 equals x squared plus 3x minus 10. So if I factor, I have to multiply to a negative, which lets me know I have a plus and a minus. So if I do plus 5 minus 2, that's going to add a positive 3. Okay, so from here I get x equals negative 5 or x equals positive 2. Okay, so step 1 gave me 2 values. Step 2 gave me 2 values. So we are going to have a mega number line here. And when you have a number line with this many intervals, you're not going to have to do an inequality for each one. Okay, so we'll do this step together, step 3 and 4. So when you're making your intervals, you have 1, 2, 3, 4. So 1, 2, 3, 4. So I have to put them in order from least to greatest. So what's the lowest number? -5. Then what? -2. Then +1, +2. Okay, so my intervals are still going to follow that same pattern where it's x is less than -5, x is between -2 and -5, x is between -2 and 1, x is between 1 and 2, or x is greater than 2. Okay, so for this one, I am going to, like I said, I am going to let you use the pattern on it. We're going to pick out test points. So if I were to do a test point that's less than -5, I would choose -6. In between -5 and -2, I would choose -3. In between -2 and 1, I'd choose 0. Between 1 and 2, I'd choose 1/2. Greater than 2, I'd choose 3. Okay, so like I said, for this one, I'm going to let you use your pattern, which means you only have to do the plug-in for one of these intervals. If you want to do 2 of them, you can. I do recommend doing at least 2 to make sure you didn't make a mistake on one. Because if you get 2 next to each other that are true, or 2 next to each other that are false, that cannot happen. So based on the test points that we chose, which one do you think is going to be the easiest for us to compute? 0. So that's the one I would do. Okay, so I'm just going to extend these lines. Okay, so if I plug in 0 to the original problem, I have 0 over 0 plus 2, which is 2, plus 1 over 0 minus 1, which is -1, and that's less than 3 over 2. Okay, so this is 0 plus -1, so I have -1 is less than 3 over 2. Is that true or false? True. Right? -1 is less than 1.5. So if that is true, what should this one be? False. And then this should be true. This should be false. This should be true. So you have 3 different intervals that are true, which means your solution is going to be those intervals. Okay? So if you have more than 3 intervals, just show work for 1 interval. Okay, so if it's more than the 3, you can just use the pattern for that. That is fine. Okay, so your solution is everything that's true. So it's x is less than -5, or x is between -2 and 1, or x is greater than 2. So that whole thing is your solution. Okay, all of those intervals together. And then your homework isn't due tomorrow. It is due in 2 days.